Hi everyone, welcome to today's learn. So today we are going to talk about another technique that we have used in data preprocessing, that is handling categorical data. So what are non-numeric data or categorical data and how to handle the categorical data in machine learning? The data that we have collected for building the models, which may contains both numeric as well as categorical data. Algorithms in machine learning designed to work with numeric data. So how to handle categorical data? So we are going to see the methods or techniques that we follow to convert from categorical data to numerical data. Here we have few of the techniques that we follow to handle the non-numerical data. One-hot encoding. So this technique is used to convert category variables into a binary vector representation. If we take an example, a feature like color with values red, green and blue. So you can create three binary features like color red, color green and color blue. Basically it creates three different columns. For each data point, only one of these binary features will be active. So this way, one-hot encoding will convert categorical data into a numerical data. And the next one is label encoding. In this technique, each unique categorical value is assigned to a unique integer value. For example, if you have a feature color with values red, green and blue, you can assign them integer values of 1, 2 and 3 respectively. And the next one is ordinal encoding. This is similar to label encoding. In ordinal, each unique category value is assigned to an integer value. The next one is binary encoding. In this technique, each unique categorical value is encoded as a binary number and each digit of the binary number is treated as a separate feature. For example, if you have a feature like city with values New York, Chicago and Los Angeles, you can encode them as binary numbers 0001, 108 respectively. And the last technique is embeddings. This technique is often used for high-dimensional categorical data, which involves mapping categorical variables to a low-dimensional vector space, where similar categories are placed close together. This approach is often used in deep learning models. Let's see one by one in deep. So here we see how to perform one-hot encoding or dummy encoding. In pandas, we have getDummies function, which is used to convert categorical variable into a numerical variable. So for any categorical variable that can take k values, k dummy variables are created. Let's say, for example, we have a column like sex, which contains male and female as two categories. So after getDummies or after one-hot encoding, we will get two columns with the male as well as female. In scikit-learn also we have one-hot encoder function. Using this we can convert categorical data into numerical data. The next comes label encoding. In label encoding, encodes target labels with value between 0 and n classes minus 1, which means let's say we have a column color red, green and blue. Each color will have 0, like red will assign to 0, green will assign to 1 and blue will assign to 2, which means three features or three categories will be between 0 and n classes minus 1. In scikit-learn we have label encoder algorithm, so directly we can use and it will basically convert the categorical variable to numerical data. Next is ordinal encoding. So ordinal encode category features as an integer array. The input to this transformer should be an array like of integers, and the features are converted into ordinal integers. So this results in a single column of integers like 0 to n categories minus 1 per feature, similar to label encoding. So in scikit-learn we have ordinal encoder function we can directly use for converting category to numerical features. And the next comes the frequency encoding. So in this way, which encodes categorical variables in a manner that preserves the information contained within them. So basically, it calculates the frequency of occurrence of that particular target label, and which identifies at what percentage of that particular label is present in that feature, and assign to that frequency value to that particular label. For example, each category in category variable is replaced with frequency of its occurrence. If a variable has categories A, B, C, and D, and A occurs 20 times, B occurs 10 times, C occurs 5 times, and D occurs 15 times, then they would be replaced with 20, 10, 5, and 15, because it is the frequency that is these particular labels are occurring in that feature. And in some scenarios, we will divide it by the total length of the feature or the total length of that particular data, and we will get the percentage frequency and we will assign to that particular category. That's all for today, guys. Thank you for watching the video.